All right, so we're going to look at the different forms of linear equations. We have slope-intercept, point-slope, standard, and recursive. So our directions here say that in each row we're going to first circle the rate of change. All right, so let's go do that first. So with our first equation here, in slope-intercept form, y equals 3x minus 2, we can see the rate of change here. It's the 3. In point slope, it also shows up here. Now in standard form, don't mistake this 3 to mean you can always see the rate of change in standard form. You cannot. And then in the recursive formula, it tells you how to get from the last term to your next term. Okay? In the second equation, we have our rate of change as the m in mx plus b. Here, it's in front of the parentheses on the right. It does not show up in the standard form. There it is in recursive. In the third one, we have negative 2/3 as our rate of change. Negative 2/3, nowhere to be found in standard. And then minus 2/3 at the end of that one. Okay. For question part B, name the point that describes the y-intercept. Well, the y-intercept in the first equation, the first row, is negative 2. In the second one, it's 7. In the third one, it's 3. So those showed up here. I guess I shouldn't circle that since part A said to circle. But here, we see our y-intercepts. And part C, name the point that describes the x-intercept. Now the x-intercept is not shown to us. It's not visible in any of these 4 forms of the equation. But the simplest way to find the x-intercept is to find an equation where we could substitute 0 for the y value. The easiest place to do that is in the standard form. Okay? In standard form, if we are substituting 0 for the y value, what that really does is just takes that whole term and makes it go away. It became 0. So then I'm solving just a one-step equation. Since I'm left with 3x equals 2, I solve that by dividing by 3. X is 2/3. That's your x-intercept. In the next one, when I substitute 0 for my y value, the whole minus 4y term is gone. Therefore, I'm left with just x equals negative 28. That's my x-intercept, negative 28. When I do the same thing in the third row there, 2x equals 9. So I'm left with 2x equals 9. I divide both sides by 2. X is equal to 9/2 or 4.5. So which equation do you prefer for finding the rate of change? Well, I'm not even going to write an answer to that one because there are 3 very good answers. So you could identify for yourself whether you prefer slope-intercept, point-slope, or recursive. As we circled in blue for part A, we can see the rate of change in any of those 3. So you pick the one you like, tell me why. Number 3, which equation do you prefer for finding the y-intercept? Well, I think there's a pretty obvious choice there that slope-intercept is the most obvious. It makes the y-intercept the most obvious because it's sitting right there staring at you. It's the b term. Now, the only other choice, the only other thing you could even give consideration to would be if you said that in the recursive formula, I can see the y-intercept as f of 0. Well, what I would say to you is we don't always have f of 0. If you're lucky enough, sure, we can see the y-intercept there. But we often are given f of 1 or f of 2 to start with instead of f of 0. And number 4, which equation do you prefer finding the X-intercept? Well, again, none of them make it obvious. I think you would probably prefer the standard form. And the reason for that would be when you sub the 0 for y, you're left with simply a one-step equation to solve. Okay, so on the other side of that, we're going to now look at some multi-step equations. So this is all review, okay? What does it mean when you have solved an equation? So we defined that the first week of school. To solve an equation means to determine all the values that make the equation true. So all the values that make the two sides of the equal sign, the left side and the right side, equivalent. So explain how a linear equation can have more than one solution. Now, there are a lot of equations that have more than one solution. This one is specifically asking us about linear equations, though. And the only way a linear equation can have more than one is if it has infinitely many. Okay? It cannot have 2 or 3 or 4. So the only thing beyond one solution that can happen with a linear equation is if it has infinitely many. And the way that happens is when both sides of the original equation are actually equivalent. Now they would be in disguise. A very simple example would be something like this. If we had 2x equaled 5x minus 3x, and we solve that, the answer is we have infinitely many numbers that work there, because this is a statement which is always true. 2x always equals 5x minus 3x, no matter what you substitute for x. And then we've got 4 equations to actually practice solving. So our first step should be to simplify each side on its own. Simplify can mean 2 things. It can mean distribute and or combining like terms. Well, we do have parentheses on the right, so we'll distribute here first. So that's 6x minus 2. We keep our 5. Now, we're going to put a plus sign between the 5 and the 6x, but it's not necessarily because we're bringing that sign down. It's because positive 2 times positive 3x is positive 6x. On the left-hand side, we don't need to change anything in that first step. Okay. The next step to simplify is to look for any like terms that are already together on one side. Well, on the left side, I have a 12 and a minus 4, which makes 8, and then plus 6x is equal to, on the right-hand side, I have 5 minus 2, which is 3, and I have plus 6x. We have variables on both sides, so we need to cancel one of them. Now we normally cancel the smaller amount of x's. We have 6x on both sides though, so there is no smaller amount. So let's just say, okay, I'm going to cancel this one on the left. So we do that by subtracting 6x, but already that feels a little mysterious here. Something's up. We get 8 equals 3, and there are no more variables left. So whenever that happens with linear equations, when all of your variables cancel, it's either going to be an equation with no solution or one of those with infinitely many that we tried to describe above. Well, we have to look at what's left. We're left with a statement that says 8 is equal to 3. And I would ask myself, when is 8 equal to 3? Well, never. It can't be equal to 3. So this is no solution whatsoever. There is no value you can substitute in for both of these x's in the original problem, and the two sides come out equal. Number 8. We have parentheses on both sides, so we're going to distribute on both the left and the right here, so that would become 10x plus 20 is equal to 3x plus 15 minus 19. Now we look to see if we have any like terms. I don't have any on the left, so leave 10x plus 20 as is. But on the right, I can combine 15 and negative 19. So that is 3x minus 4 on the right. Cancel one of the x terms, either 10x or 3x. I'll get rid of the 3x by subtracting it on both sides. So I'm left over here, don't lose the sign, negative 4, the sign in front of the number stays with it, is equal to 7x plus 20. I need to cancel the minus 20, the 20, so I will subtract 20. So I'm left with 7x is equal to negative 24. To cancel the 7, I divide both sides by 7. And here we are left with a fraction that does not simplify and does not divide into a nice, neat decimal. So we are going to keep this fraction, do not round. Number 9, we're going to distribute on both sides. Now be careful on the left here. That minus sign is part of the 3. So when you distribute, you're distributing negative 3. So the 7 I will leave as is. Negative 3 times 4x is negative 12x. Negative 3 times 2 is negative 6. On the right, 6 times 2x is 12x. 6 times 3 is 18. And then I have a minus 17 to include at the end. Like terms, on the left, I have a 7 and a minus 6. That makes 1. I still have minus 12x there with it. On the right-hand side, 18 minus 17 is positive 1, so 12x plus 1. I have variables on both sides, so I need to cancel one of them. Since negative 12x is smaller than positive 12x, I'm going to cancel this negative 12x. To do that, I'll add it to both sides. Add 12x. So I'm left 1 is equal to 24x plus 1. Subtract the 1 on both sides. So 0 is equal to 24x. And if I divide both sides by 24, I'm left with x equal 0. That does not mean there are no solutions. That means there is exactly one solution, and that number is 0. Number 10. Again, distribute on both sides. 2x plus 2, 2x plus 2 is equal to 6x minus 18. 2x is smaller than 6x, so I will subtract the 2x, leaving me 2 equal to 4x minus 18. I will add 18 to both sides, giving me 20 equal to 4x, and then divide both sides by 4. X is equal to 5.